Hello and welcome everyone to another episode of Altitude. So glad to be here today with you. Today I have an awesome guest, super excited to talk to and work with Mitch Connors, who is a senior software engineer at Aviatrix. Mitch, welcome to the show.
Thanks, Brian. It's great to be here.
Yes, so I know we have all kinds of delightful things to look forward to on today's episode. Cool terms like service mesh and containerization and Kubernetes and all this stuff, which still kind of sounds like Greek to me. So I'm hoping we can unpack that a little bit. But backing up first, tell me just a little bit about your career. What led you to Aviatrix? What were you doing kind of prior to that?
Well, I've been a software engineer for 18 years now, and I won't bore you with the whole story. Been at a variety of companies over the years, some startups, as well as some bigger names like F5, Amazon, and Google. Google was actually my most recent employment before coming to Aviatrix. I had the privilege of working in open source for Google on the Istio project for 4 years. And then I joined Aviatrix about 9 months ago when some of my favorite Googlers from the Istio project came and joined. I just had to go with them.
I didn't know you were at F5. I was at F5 many moons ago. That would have been 2007 to 2012. Were you there at that time?
No, I would have just missed you. I joined in 2015.
Oh, what were you working on? What part of the product?
At F5, I owned the APIs. So that included I control REST, I control SOAP, and TMSH.
Got it. TMSH and iControl. Good stuff, man. Yeah, I remember that. So, what's it like coming from, a big, complex, highly organized company like Google to a startup like Aviatrix? And for you, that's probably, since you've worked for startups before in the past, not quite as revealing a question as it might be for someone jumping ship for the first time. But still, I think I would like to hear your 2 cents on that.
I think the big change is always in scope. I'll say for a large company, Google did a great job of giving their engineers a good deal of autonomy. And I really enjoyed that while working for them. There's a lot of corporatization that's happening, but it was still the most uncorporate corporation I've ever worked for. That being said, coming to Aviatrix, I've had the opportunity to do things like get involved in product management, get involved in some of our publicity efforts to make sure that folks are aware of the way that Aviatrix can be used with container networking. Those would have been very much outside of my scope at Google, but of course, a startup affords a great expansion in scope. And so it's been a really great experience so far.
Yeah, glad to hear it. That's cool. Now, the obvious elephant in the room is why would you, as an expert in service mesh and containers, come over to a company like Aviatrix that currently doesn't use service mesh or containers in the data plane? First, I just want to understand what the deal with containers is insofar as, I mean, I understand the basic technology and I understand the appeal of, micro workload distribution. But why do you think containers has been so successful in the industry? What is it that containers is really doing in the industry that, regular virtual workloads are not doing?
I think the initial success of containers, looking over the last 6 years or so, has been predominantly around the ease of orchestration. It is trivial to define your entire application in terms of every dependency it has on the system into a container and to run it portably just about anywhere. So you need to scale up your application on AWS, you need to scale it up on Azure or in your data center. Same definition. Goes to all of those locations, same scalability characteristics, same dependencies. So that combination of portability and scalability has been something the industry was looking for a very long time. There have been solutions that targeted one or the other. I can think of Beanstalk, for instance, as a wonderful solution for scalability. And if you'd like to take it outside of AWS, well, look for something else. So that solved sort of one of the two problems. But this is Kubernetes is, as far as I know, the first sort of solution that has allowed for both portability and scalability at large scale. And I think that's really why it's captured the imagination of developers all over the world.
Do you think that it's that, I don't want to say esoteric because there's so many developers involved in cloud, and cloud was originally built and positioned for developers, so it's really kind of their world that enterprise is stepping into. But from the standard enterprise perspective, containers are very esoteric, right? They're bespoke insofar as they are very oriented for DevOps folks. Do you think that skills gap or just unfamiliarity with coding and orchestration poses headwinds to containers for broader adoption?
That's a great question, and it's a little bit complicated to answer. I think that containers act a lot like any other change for large enterprises. If you think back to like 2010 to maybe 2014, cloud was this looming thing that every enterprise knew was coming, that they would need to adopt. They had no idea how to do it. And by and large, developers acted as those pioneers, for better or for worse. They went out and set up their company's cloud accounts and got applications running on the cloud. And that meant that there was productivity, there was value coming from the cloud. Oftentimes, the policy side that your more traditional IT systems and network engineers provide lagged there. So it took time for those systems to catch up, to become present in the cloud. And of course, that's where Aviatrix has a lot of its businesses in helping those network admins to manage their multi-cloud presence. I think the same thing is happening with Kubernetes. Developers are the pioneers. They're pushing the envelope. I talk to so many network engineers who tell me, yeah, I know there are some developers who put a Kubernetes on our network. I don't know what it is, but they required a bunch of IP addresses, and it makes me nervous. So it's going to take time for those enterprise policy systems to catch up with the advances that developers are demanding. I think that's a great opportunity for Aviatrix.
Well, how so? How does Aviatrix break that opportunity free for agile workloads?
Well, the container networks are like any other network, only more so. Let me dig into that a little bit. In a traditional network, it's not a great idea to use IP address as an identifier for your VMs, right? We've known for a while that we need to be using TLS or mutual TLS, even within our data centers, within our cloud VPN, in order to really understand and be confident in the identity of a given connection, because the user of that IP address may change over time. There are reasons that the network might obscure the IP address of traffic. And so IP was not a reliable identifier, but really, you could kind of get by with IP address as an identifier because they didn't rotate that often. And so if you built a network where, let's say, your firewall policies are all about subnets and IP addresses, that actually had a lot of value in a VM world. In a container world, your IP address can change as frequently as 15 to 30 seconds. As a container spins up, it does its job with a particular IP address, spins back down, and now that IP address is available for allocation to the next container that needs to spin up. So all of a sudden, that identifier that was not a good idea in the first place, but was kind of maybe good enough in some cases, it's now become more of a problem. That rotation problem has become more exaggerated with containers. And that's true along most dimensions of container networking. The things that were minor problems for VM networking become major or significant problems for container networks.
Okay, and you're saying that Aviatrix is helpful there because through distributed cloud firewall and attribute-based security, we're able to latch on to identity from a label or attribute perspective, like a tag, which gives us better flexibility for containerized workloads or a better nuanced understanding of policy control. Because IPs, I completely agree, from a policy perspective in cloud are shadows and dust.
Yeah, that's part of the picture. Like already today, we've helped our users move beyond IP-based identity for their VMs. They can use tag-based identities when writing policies. They can use auto-scaling groups and a whole number of attributes. And so we can extend that same functionality into Kubernetes and say, you can use container attributes to write policy for your traffic rather than needing to be IP address dependent. So that's valuable, but I think we can actually zoom out and say that Aviatrix has always been in the business of providing this consistent control plane that works across all the environments you need to operate in, so that you don't need one scheme for your on-prem and another scheme for your AWS and another scheme for your Azure. It sort of provides a level playing field across all those environments. And the way that we think about container networks is that they're just another type of environment. You should be able to learn how to write firewall rules for your entire application, VMs, on-prem, bare metal, Kubernetes, write it once and have it apply everywhere your application runs. It's not that there's no growth for Aviatrix to do in this space. Certainly there's engineering effort that's involved there, but it's just another chapter in the same story we've been telling all along.
I think that containers to a lot of enterprise networking types and that have now transitioned into cloud network engineers, I think they see containers as kind of black magic insofar as they're not really part of the deployment or application lifecycle there. it shows up in a subnet or a VPC or a VNet, and then they're kind of responsible for it, right? Now they have to worry about routing to the container ecosystem or tier that's in there, and then they also are responsible for security. And I see a lot of them throwing up their hands and just like, I don't have a huge background in Calico or Istio, and container security is just something I don't have the time or energy to really unpack. So they kind of just let the developers do what they do inside the VNet or VPC and say, whatever goes on in there is fine, as long as it doesn't leave the VNet and present a threat in that way, that's fine. Or if it does leave the VNet, then it has to come through my DMZ and know about it. But the whole container to container security play and workload to workload security play, I see a lot of just apathy. They're just like, it's too much for me to handle.
And there's a reason for that. I don't think those personas or those people that you're interacting with should feel bad about it. There's this sense of guilt in a lot of network engineers that it's, or really any discipline, is cross-cutting across your application wherever it lives. I've not caught up with the cutting edge. I'm not super familiar with it. And I know I need to figure this stuff out, but I just don't have time because I've got all this existing workload. When Kubernetes showed up on your network, it's not as though your full-time job administrating the network just all of a sudden disappeared and you could move to Kubernetes. That is the experience of your typical app dev. You spend some time transitioning from one system to the next. It took a while to get your app from on-prem into the cloud, but eventually you got there and you got to forget about on-prem. Well, your network engineer did not get to forget about on-prem because something still runs there. Who knows what it is, why it's there? Maybe nobody knows how to migrate it, but it's there and it's going to be there maybe indefinitely. Your network engineer has to remember that. Likewise, the developer containerizes his application and he can forget about VM auto scaling groups and Elastic Beanstalk and all of the skills that he had to learn for VM-based orchestration because his app is moved. It's now in containers. The network engineer doesn't get to move on. They have to understand their network from layer 3 all the way up to layer 7 for VMs, for bare metal, for on-prem. So it's a very different problem to solve for engineers who sit on top of everything, who provide a platform for the application to run, than it is for the engineers who are actually writing the application.
Let's do a little game. I'm going to try to talk about containers from a very basic perspective for the benefit of myself and the listeners. And then at the end, you give me a letter grade in terms of how I did, okay?
Sounds good.
A container is a micro instance of an application or a workload, a piece or a component of an application, almost like a user process that runs inside of a virtual machine in an orchestrated ecosystem. They collaborate together with other containers to form a cohesive platform or a cohesive whole application delivery stamp. And the way containers are organized is you have essentially one or more containers that have the same function or namespace. This is a pod. And then pods dwell inside of a node, which is the parent virtual machine, and then multiple nodes that are all bound together with the same purpose or outcome is called a cluster. Is that correct?
Yeah, I think you've got it. A pod can contain more than one container, but as a rule, it's pretty safe to think of it as a single container for a single purpose.
Okay.
And just like VMs, you might need 1 or you might need 10, depending on the demand on that application at any given point in time. If you're in e-commerce, you're very familiar with Q4 and the need to scale up for Black Friday really dynamically. The big difference is going to be that when you scale up VMs, typically you're looking at maybe a 15-minute lead time for the VM to get bootstrapped with your orchestration system, maybe using Chef or Puppet or something along those lines. And then you're going to need for it to connect to the network and all of these things. Whereas containers, typically you're talking on the order of 5 to 10 seconds. That's the major difference. So the problems are all the same. Defining your application, deciding which things need to scale independently of one another. That all is completely consistent. The difference is that scale can happen much, much more quickly, much more responsively than you're able to accomplish in VMs.
And isn't it that the Kubernetes brain, as it were, is really the one that's in charge of scaling the pods insofar as it sees different signals for demand or outcome and then decides to build or destroy containers based on maybe parameters or guardrails that are set. Is that right? So humans aren't actually in there second by second, day by day saying build more pods, take away more pods. They just set goals and Kubernetes just bends to that outcome.
Yeah, typically you declare a type of pod known as a deployment. It's not a type of pod, it's an abstraction over pod. It says, this is what my pods are going to look like. And by the way, here's how many of them I want you to run. And then you attach a horizontal pod autoscaler to that deployment, which says, rather than me giving you the number every time it needs to change, here's just some rules for how to scale it. The default rules are pretty simple. Like if you're seeing 80% CPU utilization or 80% memory utilization across my pods, something's going on. It's time to scale up and have more compute, more memory available to this application. Likewise, if I'm down below, say, 40%, that's kind of wasteful of resources. It might be time to scale down.
Got it. Now let's bring Istio in on this mix. Why is Istio important? Sounds like Kubernetes kind of has it all buttoned up, right? I mean, it's got great orchestration, it's got great deployment and management capabilities that are all automated and repeatable. It will babysit pods and scale them and nurture them. And so once I've done my hard work as a developer and, work through Kubernetes to set up my environment, I should kind of be able to kick back. Why do we even need Istio? What is it doing that Kubernetes isn't doing?
Yeah, that's a great question. Kubernetes is an excellent solution to a very particular problem, the problem of orchestration. What all applications need to be running and where do they need to run? If you give Kubernetes a pool of resources, here's all the computers that can run whatever application. You give it requirements, here's all the applications I need you to run, and it'll dynamically allocate and figure out, here's the best way to run all of these applications given the resources I've got today. And it's great at solving that problem. But if you look back to the original Google white paper that sort of kicked off the Kubernetes project for container orchestration, there's a little sentence towards the end of the paper that says, and by the way, somebody should figure out networking for this thing. And that sentence is where Istio came from.
I see.
And that's not a slight to Kubernetes. That was not an oversight on their part. It's simply that was not the problem they were attempting to solve. So Kubernetes works very hard to solve the orchestration problem in a very compelling manner and gives you the bare minimum networking capabilities that you need in order to use that orchestration. What Istio does is provide perhaps the network that you hoped to have for that sort of system, the abstractions that you would like to see, particularly application layer abstractions for your network as it runs on Kubernetes.
I see. Now I kind of grok why so many Istio experts are coming to work at Aviatrix, especially from GCP, insofar as Aviatrix kind of takes that same approach for cloud, multi-cloud all up, right? Which is there's a lot of smart people in cloud developing a lot of solution-centric platforms, PaaS and SaaS and AI and ML and web apps and Beanstalk and all these things. And they're like, we're solving these specific use cases with these amazing services. But networking, someone else will figure that out, right? That's kind of, I don't want to prey on the developer stereotype, but it's too tempting for me to not take a shot at, which is developers are so good at solving, deliverable problems around a specific use case. Like I have to build a platform that can understand human text and turn it into speech, or vice versa, right? Text to speech, speech to text, and they do a gorgeous job of it. And then they're like, well, here, some other people, you figure out how that connects to the network and how that functions, because they're so busy and focused on the thing. So I get it now. So Istio comes around because networking orchestration really wasn't the reason Kubernetes was born. That was supposed to be solved by something else. So Aviatrix solves cloud networking and makes it straightforward, and then Istio can help solve containers networking and make it straightforward.
Yeah, and Istio was really about advancing the technology side. Google's always been great at doing that, advancing the cutting edge in technology. They're not the only contributors to Istio, but they were among the first and are still a large player in the project. When it comes to Aviatrix, though, what I see is that there's a lot of technology out there that's cutting edge, and there's a lot of companies that are building on the cutting edge, building entire business models off of that cutting edge on the presupposition that eventually everybody's going to get there. It's cutting edge today, but tomorrow or the next day or the day after, it'll become a standard for the industry. Where Aviatrix is a little bit different is we're not standing at the future looking back to our customers and saying, hey, come join us up here. Just rework your stack to be completely containers, rework your networking to be completely Istio, and then you'll have all this magical, awesome stuff. What we want to do is journey along with those customers.
Right.
By and large, those customers have a small container footprint today. They expect it to grow exponentially over the coming years. They know that's where they're headed, but the bulk of their investment today is still heavy in the virtual machine and bare metal world. So if we stand at the future and tell them, hey, as soon as you're done with all of that migration work and have no more VMs and no more bare metal left, this is going to be great. It might be 10 years before we show value to that customer. I want to show them value today.
Got it.
That's not to say Aviatrix versus Istio. Rather, the way that I think of it is we provide an on-ramp for customers so that they can iteratively get towards that end goal, which is eventually to have the vast majority of their application running in containers that are orchestrated wonderfully and have lots of networking magic. But there's going to be lots of intermediate steps in between, and we want to be at each step with them along the way.
Yeah, I mean, there's no question that containers are great as long as you have the right team, the right tools to use them and exercise them. They are especially good at modern, I know the term modern is overused and confusing, but newer greenfields, there's an app for that applications, typically TLS based, HTTPS based. The problem with enterprise is that they have so many applications, legacy or heritage applications, that they have to run kind of into perpetuity, that containerizing some of those that were built and designed before containers ever showed up is kind of a mighty task, if not impossible. So I see value in Aviatrix insofar as, like you said, it's like a single, what did you say, like a single on-ramp?
Yeah.
Because they're going to end up with dozens of different application environments that they have to secure and connect and get to talk and to collaborate. And so it's going to be a big melting pot, basically. I do think containers is the way forward for a lot of new greenfield stuff, but how much brownfield stuff will actually make it over from just the basic migration, lift and shift into containers, I don't know. Some of it is, but it's probably hard.
I got a great illustration of that early on in my career, a firsthand look. My first software engineering job was at a Fortune 50 financial services company. This was in about 2006. Well, the lesson that I learned was that the legacy lives forever. Sometimes, not always. There are companies that manage to migrate all of their infrastructure off, but there are always going to be those that don't. This particular financial services company I worked at, I was building software to help a modern Windows environment interact with the old IBM Telnet system, because by and large, this company's systems infrastructure all still ran on mainframes. And getting mainframes to interact with Windows computers is not the most trivial thing. So in 2006, I was writing software systems that had been installed in 1976. And as far as I know, those systems are still in place at that company today. The lesson there is that you've got to consider the legacy when you're building a platform. If you're a software engineer, you get to move on from legacy 9 times out of 10. And the engineers, even at those financial services companies, they're not writing, PL1 or what are the old IBM languages for mainframes. They're writing in modern languages, but they can't ignore, if they're writing the platform, if you're writing the network policy, you have to be aware of those legacy systems' existence. You have to be familiar with them, and you have to write a platform that supports them. So I think of the modern software development environment the same way. Sure, people move most things from on-prem to the cloud, but on-prem is never going to go away altogether. People are going to migrate most of their VMs to containers over time, but VMs are not going to disappear altogether either. We need holistic solutions that allow that legacy to coexist for long periods of time, get built on afterthought.
No, that's a great observation. I wonder if in some ways, moving forward, if we roll the clock forward, say 10 years from now, and those applications that were initially built today or last year in containers, do you think that containers breaks the wheel insofar as it gives the opportunity to reinvent and replatform in a way that a mainframe would not? So I guess what I was saying is that, is it kind of a ultimate solution for addressing legacy lock-in?
No, I don't think so. I'm a firm believer that everything old will be new again. In technology, we run through these cycles of moving from shared compute to isolated compute has sort of been a pendulum that's swung back and forth. it's not just backwards, right? Containers are not the same as the mainframe. And yet they allow shared access to compute resources in a very similar way. That pendulum will swing back again in the future at some point where we say, well, containers, you shared compute and there's some isolation problems with that. So maybe we'll find a better way to isolate compute than VMs and bare metal offered us in the future. But there will be a new wave. There will be a new technology that overtakes everything, and the legacy will live on. That new wave will need to account for on-prem and bare metal and VMs and containers. So the problem gets bigger with time, not smaller.
Yeah, that's probably true, although it's kind of a dystopian future. But I would agree it's probably true.
That problem is complexity management, right? The problem is managing the complexity of all of that legacy.
Yeah.
And that is the principal job of a software engineer.
Yeah.
It is to teach computers to manage the complexity that we have in our lives for various reasons. So while it's dystopian in terms of the size of the problem growing with time, I do believe that we can solve those problems in compelling ways with good software engineering. And that's why I'm here on the team at Aviatrix.
So, final question, Mitch. This has been a really fun conversation. What are some things you think that Aviatrix is doing at the software level that is inspired by Istio and the approach of solving networking for containers? So, even though Aviatrix say we don't use Istio as a component of our platform, what are some of the things you learned, wisdom and knowledge gained from working so closely with containers and Istio that you're applying here in your job at Aviatrix?
I think one of the number one things that I've brought from the Istio project over to Aviatrix is a lesson in usability. We in Istio really struggled with having users upgrade promptly. We would often have users report outages or bugs. And when we got down to the root cause of those outages or bugs, we would find that they were issues that we had resolved perhaps 1 or 2 years ago, and that particular user had not stayed up to date. That's something we're paying attention to a big deal as a company at Aviatrix today, as we've had similar problems. We're looking for similar solutions on how to make upgrades easy and transparent for our users so that they naturally stay up to date and are getting the best experience of the software that is possible for them without putting tons of burden on them to just, every week go check and make sure there's no updates available. And if there is, spend 6 to 10 hours upgrading your system. That's not an ideal user experience, and it's always going to result in customers falling further and further behind our software and experiencing more and more bugs that we've already solved.
Well, Mitch, that was a very fun, enlightening conversation. Enjoyed every minute of it. Thank you for gearing down and doing containers for basics for myself and some of the listeners. I appreciate your patience there. And also, thank you for springing forth and thinking so intently about the future and how containers plays in that. So, fantastic episode. Hope we get to get you back on the show in a couple of months and we can see how else Istio and containers have inspired Aviatrix. I would love to learn more. Thank you.